Welcome to this explainer. Look, if you spend your days working with industrial rotating machinery, you already know the deal. Getting that shaft alignment absolutely perfect, it's kind of like half art, half grueling mathematics, right? Just a fraction of a millimeter off and boom, you're looking at premature bearing failure, crazy vibration, and some seriously expensive downtime. So today, we're going to unpack how this highly specialized app, the Shaft Alignment Calculator, literally transforms that whole tedious, math-heavy process into a super streamlined digital workflow. Let's just dive right in. Okay, I want you to picture something for a second. Imagine you're deep underground in a pump room, or maybe tucked way back inside a massive processing plant. The ambient noise is just deafening, you've got absolutely zero cell service, and you're down there wrestling with delicate dial indicators while trying to scribble out complex math on this dirty, grease-stained notepad. I mean, we've all been there, haven't we? You make one tiny little arithmetic error on that pad, and suddenly you're ripping out shims you just spent 20 minutes carefully installing. It is beyond frustrating. Well, today we're checking out a dedicated tool designed specifically to eliminate those exact on-the-floor headaches. We're looking at version 1.2.5 of the Shaft Alignment Calculator. And honestly, what makes this app so cool is that it was built strictly for the field. There are no battery-draining, complex animations, just a lightweight interface, which means it absolutely won't kill your phone halfway through a shift, and, best of all, you don't need a drop of Wi-Fi or cellular signal to run your calculations. Section 1. Mastering Calculation Methods. So, depending on your machinery setup and the specific protocols at your plant, you might be using a couple of different alignment techniques. Now, whether your site requires the traditional rim face method, utilizing 4-point face and rim readings, or if you're using the reverse indicator method with rim-rim readings from both sides of the coupling, this app has you covered. It provides dedicated, highly accurate calculation modes for both of them, which essentially means you can finally stop carrying around different cheat sheets for different machines. And the user interface just adapts seamlessly to whatever method you choose. With a standard rim face setup, you get these nice, clear entry fields for the top, bottom, left, and right readings for both the rim and the face. But switch over to the reverse indicator method, and watch. The screen instantly transforms. It now asks for gauge span, and it actively gives you fields for bar sag values on both the stationary and movable sides. It actually automatically compensates for that physical bar sag. And let's be honest, that is historically one of the absolute easiest places to make a manual math error. Section 2. The single foot simulation. Okay, think about this for a second. What if you only had to adjust a single set of feet to perfectly align your machine? Usually, as millwrights, we're adjusting both the front and rear feet back and forth, right? It's this whole dance of trial and error. But sometimes adjusting just one side is totally enough to bring the whole system right back into spec. And here's where it gets really smart. If your alignment can be fixed by moving just the front or rear feet, the app's single-foot simulation completely recognizes that. The interface will immediately light up with a suggestion, something like front foot only, and it'll recommend the exact adjustment, like 4 units down. Plus, it gives you the acceptable adjustment range, and, this is crucial, your predicted residual misalignment. It literally shows you exactly what your rim and face readings will be after you make the move. It completely removes the guesswork. You know your final result before you even pick up a wrench. Section 3, Customizing your workflow. Let's jump into the settings menu because here you can lock in your site-specific rim and face style and axial tolerances. By plugging in your facility's exact requirements, let's say a tolerance of 5 and 3, the app instantly knows exactly what good looks like for your specific machines. Oh, and a quick side note. If you set these tolerances to 0, those single-foot adjustment suggestions we just talked about, they won't display because, well, the app thinks absolute perfection is required. Beyond just tolerances, you can rapidly customize your workflow with a whole series of really robust toggles. You can activate swap gauge setup if your dial indicators are set up to read from the driven machine back to the motor rather than the standard way. Or you can turn on average mode, which actually adds extra input fields so the app can calculate based on the average of 2 distinct measurements. You can even toggle on offset fields if you're dealing with thermal growth and you need to target very specific offset directions. The whole interface essentially just flexes to fit how you work. Back on the main input screen, a simple tap of that blue face button instantly toggles your gauge readings between plus equals closed and plus equals open. I mean, if you've ever stood there second-guessing which direction your dial indicator was actually sweeping, yeah, you know this little button is going to save you some serious mental gymnastics right there at the machine base. So what all this customization does is it essentially distills a very complex, highly error-prone workflow down to 4 incredibly simple, repeatable steps. Step 1, enter your machine dimensions. Step 2, enter your 4-point measurement readings. Step 3, verify your plus equals face button setting. And step 4, just tap calculate. Honestly, that is efficiency and execution at its finest. Section 4, built for the field. Now, imagine you just finished a brutal, multi-hour alignment. Instead of handing your plant engineer a smudged piece of paper, you just use the app to immediately save your gap distance and your final readings. You literally just name the machine, like, say, pump, input the final gap measurement, and the app generates a manual record. It saves the date, the machine name, the gap, and your final intolerance rim and face readings. And it securely logs up to 30 of these records, meaning you are never going to lose your hard-earned data to a greasy thumbprint or a misplaced notebook ever again. And hey, speaking of losing data, the developers really thought about the messy reality of actual field work. The app has a built-in fail-safe memory function. Let's say you're halfway through inputting your readings and suddenly your foreman calls you on the radio, or you accidentally swipe the app closed while wiping sweat off your brow. No big deal. Your input values are safely retained. When you open it back up, everything is right there exactly where you left it. As the app's documentation specifically emphasizes, this tool is deliberately built for the harsh, totally disconnected realities of the physical plant floor. It does not force you to go hunting around for a cellular signal to sync up to a cloud just to get your shim calculations. It is a fully standalone application. Which leaves us with one final thought to ponder. Once you've actually experienced the sheer peace of mind that comes with reliable, completely offline digital alignment, knowing your bar sag is mathematically compensated for, your single-foot shims are simulated for you, and your final records are permanently logged, how could you ever go back to doing it the old way with a dirty notepad? Thank you so much for joining me on this explainer. I really hope this deeper look gives you a fresh perspective on modernizing your maintenance toolkit. Keep learning, keep optimizing, and I will see you on the next one.